the next characteristic property of liquids what we have to discuss is viscosity. What is viscosity? It is quite common to use the terms high viscous liquids and low viscous liquids. High viscous is nothing but which is more slippery, thick in appearance, whereas less viscous which will not stick, right, which is having more sticky nature is more viscous, which is having less sticky nature, that is less viscous. This is what for a common man we can describe about viscosity. For example, oils which are more thick and which are more sticky, they are more viscous. Water which will not stick much, that is less viscous. If you take mercury, that will not stick at all, that is the least viscous. So this is what, so more thickness and less thickness is the concept, what I mean is the property by which easily we can understand about the viscosity. But more precisely, what is viscosity? Suppose if we consider a tube in which liquid flows, obviously in a tube if you consider different cylindrical layers, these are the different cylindrical layers of a liquid in a tube, then here what happens is that the topmost layer of the liquid will have certain velocity v with which it flows, and of course this is the one that gets stick. As you go inwards, the liquid flow increases, the velocity with which liquid flow will increase. On the other way around, what I will say is, suppose if you consider the central layer, then if this has a velocity v, right, then this particular layer, the speed with which or the velocity with which this layer of a liquid flows will be more than the velocity with which these two layers of the liquid flows. And as you keep moving away from the center towards the edges of the tube, the velocity of flow of a liquid decreases. This is the, suppose if you consider this is the layer which is in contact with the wall of the tube, glass tube or whatever the tube that we take, that will have very least velocity or will not be in a position to move. In fact, that is the reason that that particular layer will get stick to the wall, right. But as you come down or as you move away from the wall, as you move towards the center, the velocity increases. So either way, from the center as you move away towards the wall, the velocity of different layers of liquid with which they flow will be keep decreasing, right. Or in other words, as you come inwards from the wall, the velocity with which liquid flows in different layers will increase. If you consider that this, now if you consider that this particular layer will move with a velocity v, then this will move with a velocity some v plus v dash or small v, and this distance if you take it as x, right. Now what is viscosity? What is the reason for this decrease in velocity? The reason is that between two layers of a liquid there exists some friction. Between all such layers there exists friction. As the number of layers increasing, so here if it moves with certain velocity v, due to friction it will, due to the friction between these two layers, its velocity decreases. As you move away, it still decreases, and as you keep moving away and away, the velocity decreases. So it is all because of the friction between the two layers of a liquid. The layer at the center will induce friction in all successive layers, and the extent of that frictional force, magnitude of the frictional force, increases as you move away or as you move towards the edge. Therefore, as we are moving, as the frictional force gets the magnitude of the frictional force getting increased, the velocity with which different layers will move also decreases. So is the reason. Now, in the case of liquid like honey or oils, this friction will be more, because there in this case the intermolecular attractions are considerably high. When the intermolecular attraction is considerably high, then the friction that offered from one layer over the other layer will be more. So the velocity with which the liquid flows decreases. That is the reason that because the velocity is less, as you move away, more liquid will get stick to the wall. But in the case of water, this friction is relatively less. So in the case of water, the amount of water that gets stick to the wall will become less, right? So basically this viscosity is the frictional force acting on one layer of a liquid by the effect of inner layer, is due to which the velocity of flow decreases, is what is called viscosity. So this viscosity is again nothing but force that is acting. So now here the viscosity of a liquid we measure in terms of a term called viscosity coefficient. Viscosity coefficient. Now suppose, now if you consider these cylindrical layers, that the distance between two layers is x centimeters, area of cross section is a, distance is x centimeter. Then the velocity of flow is v centimeter per second, a square centimeter, v centimeter per second. Then the frictional force is proportional to the distance increases, right? The frictional force also increases, and as the area of cross section increases, so it is a into x by v. As the friction increases, velocity with which the liquid flows obviously will decrease. So it is F is proportional to ax by v, or now I will write this F is equal to eta into a into x by v. This eta is viscosity coefficient. Now how do you define this viscosity coefficient? We can define this viscosity coefficient as the frictional force offered by a liquid in order to have a velocity of 1 centimeter per second with an area of cross section of 1 square centimeter at a distance of 1 centimeter. So it is nothing but will give us the rate of flow, or it is the frictional force offered. It is the frictional force that exists between two liquids. The frictional force that exists between two liquids, two layers of a liquid which are at a distance of x centimeter, and differ in velocity by v. This v is actually this v. Difference in the velocity is v. This is v, this is v plus v. So, the difference is small v. That small v is the one that what we are writing. Velocity or difference in velocity. Let me write. Difference in velocity is v. Then area of cross section of this that cylindrical area, that is of course A. So, viscosity coefficient is nothing but the frictional force that exists between two different layers of a liquid having unit area of cross section and are at a distance of x centimeters or at a unit centimeter and having a difference in velocity of 1 unit. A is 1 square centimeter, x is 1 centimeter and v is 1 centimeter per second. And so, this eta is, now we will have the unit again as this is also a force, Newton per meter square or dynes per square centimeter, force per unit area, right. Now, this is but usually measured in terms of the unit for this eta is poise. This poise unit is given in respect to the scientist Poiseuille, who explained the concept of this viscosity, and to measure the viscosity of a liquid we use a apparatus called viscometer. In a viscometer, first it is again like in the case of surface tension, we take first water and then we take another liquid. So, here also in relative terms what we measure, that in the viscometer first it is the water that is taken and the flow of the liquid is water is measured. Then in the same viscometer another liquid like oil or any other liquid whose viscosity is to be measured will be taken and the rate of flow of that liquid is measured. Then the ratio that will give you how much the liquid is more or less viscous than water is what we measure, right. So, with this kind of observing the velocity within the same time, what is the amount of liquid that we can collect is what we measure using this viscometer. Here actually we will have a U-shaped tube, then the time required for the liquid to flow from one side to the other side to increase a particular height is what we measure, right, and using that we measure the viscosity. Now, this viscosity, what is the consequences of viscosity? Because of the viscous nature, many substances have acquired the property called lubrication. The lubricating property of substances like grease, the lubricating property of some of the liquids, some of the oils is all because of their high viscosity. Because of that reduced flow, it will allow, as it gets stick to the two parts, then one part, or if you it is a two objects are getting just attached to one another like a screw and bolt system where we apply the lubricating grease. As a result, it just slides over one another, but will not break up when you fit them tightly. It is because that lubricating nature, the lubricating property of the liquids is because of their viscous nature, because of the restricted flow, because that liquid will not move away from that part. So, because of this restricted flow, every liquid will acquire its lubricating nature. More the viscosity, more is the lubricating nature. Grease, which is considered to be a highly viscous liquid, is the one that most commonly used lubricating substance, right. And besides this, the other consequences of viscosity also is that the more viscous liquids will offer I will also have the smooth flow. So, wherever the smooth flow is to be maintained for a liquid, there again liquids with high viscosity are used. And when it comes to the effect of different parameters on the viscosity, like in the case of vapor pressure, Like in the case of vapor pressure, in case of viscosity also, with increase in temperature, viscosity coefficient also increases, just like in the vapor pressure. Like in the case of vapor pressure, we give the relation with the temperature with the Clausius-Clapeyron equation. Here also log eta 1 by eta 2 for two liquids, we can give it as A by 2.303 r log 1 by T2 minus 1 by T1 is. So, with this what you can understand is that with increase in temperature, viscosity coefficient increases. This is somewhat similar to the Clausius-Clapeyron equation for vapor pressure. So, log P1 by P2 is equal to, because that is also force, 2.3, there we use delta H by 2.303 r, where delta H is the enthalpy of vaporization there, 1 by T2 minus 1 by T1, right, exactly similar way. So, when it comes to the effect of temperature, which is very, very important, with increase in temperature, vapor pressure increases, surface tension decreases, viscosity increases. This is the overall picture. So, these are the specified characteristic properties of liquid which the other states of matter may not have, that vapor pressure, surface tension, viscosity. In fact, gases will have certain viscosity also, but their viscosity of gases we discuss separately, but there the viscosity of a gas does not have more significance as in the case of viscosity of liquids. So, we do not discuss at this stage normally about the viscosity of gases, but in the case of liquids the characteristic properties are this: vapor pressure, surface tension and viscosity. Other than this, diffusion is also a property of a liquid, but diffusion of a liquid is less significant than diffusion of a gas. So, diffusion separately we do not discuss at this stage for the liquids. Like that, for liquids the specific characteristic properties what we have to discuss are only vapor pressure, surface tension and viscosity. With this, the topic of liquid state is completed, and so with this lecture the gaseous state, liquid state, the two states of matter we have completed. Next state of matter, that is solid state, is what we have to see in the next lecture: coefficient of viscosity. Coefficient of viscosity. As here we told that viscosity is the frictional force acting between two layers of a liquid. It is a frictional force acting between two layers of a liquid, due to which the relative flow of a liquid varies. So, here if suppose this layer, this cylindrical layer has a velocity v, then as you come inwards the velocity increases to v plus v, and these two layers, if you expect it, if you say that they are separated by a distance x centimeter, then obviously the flow of the frictional force, the viscous frictional force acting, between these two layers will be proportional to area of cross section of the liquid into velocity v, velocity difference, the velocity difference, the difference in velocities of the two layers, because that is actually the one directly affected by frictional force, right. So, AV by x, where A is the area of cross section of the liquids, and V is the difference in velocity between two layers, difference in velocity of two layers. X is the distance between the two layers, distance between two layers, right. Now, for this, when f is proportional to a into v by x, I can write this f as equal to eta into AV by X, where eta is called viscosity coefficient. Viscosity coefficient. How do you define this viscosity coefficient? The viscosity coefficient is now nothing but it is the frictional force that exists between two layers of a liquid which are separated by a distance x, because as the distance increases, the frictional force decreases, right? So it is the frictional force exists between two layers of a liquid which are at a distance of x with a difference in velocity of v and having a area of cross section A. That frictional force that exists is what we call viscosity coefficient. Now, higher the viscosity coefficient, obviously lesser is the velocity of the liquid. So here what you can understand easily is that, so viscosity is also nothing but the force, it is a frictional force. So the viscosity also, units of viscosity, because it is a frictional force, so it will have the unit of Newton per meter square, dynes per square centimeter, but in general it is given with the unit poise. Poise is the unit that is given in respect to the scientist Poiseuille, who worked extensively on the viscosity and velocities of flow of liquids. Okay. And now when it comes to the factors affecting the viscosity, temperature is one very important factor that affects the viscosity, that with increase in temperature, viscosity also increases. This is because with increase in temperature, the frictional force acting also will increase. So as a result, viscosity coefficient also increases. Now this is the effect of temperature on the viscosity is somewhat similar to what we the effect of temperature we discussed it for vapor pressure. Like here, if eta 1 and eta 2 are the viscosity coefficients of the two liquids, then log eta 1 by eta 2 equal to A some constant by 2.303 r 1 by T2 minus 1 by T1. This is similar to Clausius-Clapeyron equation which we wrote it for vapor pressure. In the case of vapor pressure, we wrote log P1 by Pt is equal to delta H. Delta H there, delta H is nothing but enthalpy of vaporization. Delta H by 2.303 into 1 by T2 minus 1 by T1. That is the Clausius-Clapeyron equation for vapor pressure. So here vapor pressure is also a force, certain kind of a force. This viscosity is also a certain kind of force. So therefore they both are having the similar effect of temperature, right? And this effect of temperature, overall if you summarize, in the case of vapor pressure, increase in temperature, with increase in temperature the vapor pressure increases, with increase in temperature viscosity increases but surface tension decreases, right? Then consequences of viscosity, the very important consequence of viscosity or the application of viscosity, whatever you call, is the lubricating nature of liquids. Suppose if you take two different liquids like again water and oily like liquids, castrol or any other liquid, or lubricating oils, if you take, or if you take the oils like grease is one oily like liquid which is used most commonly as lubricant. The reason for grease to use as lubricant is because of its high viscosity. The relative flow of the layers of that liquid is very less, so that grease will get stick between the two parts which are attached to one another. Like in the nut bolt arrangement, we use the grease as a lubricant, so that if you use that grease, then even in spite of the tight fitting, neither the bolt or nut or whatever to which it is, the joint to which it is attached will not break. right. So that acts as a lubricant. This lubricating nature is because of the high viscosity of that particular liquid, and to measure the viscosity we use an apparatus called viscometer. In the viscometer, again, first we take the water, and the flow of the water is first determined. Then into the same viscometer, this oily like liquid, when it is taken, its flow is again measured. Then the relative flows are taken into consideration, by which the viscosity coefficients of the two are being measured, right. So like this, the relative viscosity or the viscosity coefficient of one liquid is measured in relative to the viscosity coefficient of pure water. So this lubricating nature of oily nature of liquids is one very characteristic application, consequence of the property viscosity, right. So this vapor pressure, surface tension, viscosity, these three are the characteristic properties of liquids, which normally we do not discuss for other two physical states of matter, that is solid or gas. In case of a gas, certain times it is required to know about the viscosity of a gas, but relative to other properties it is less significant. So we do not discuss much about the viscosity of gases at this stage. For solids, of course, in the graphite like substances we do require it, but again it is not so characteristic for all the solids. But in the case of liquids, for any liquid, it is very important to know the vapor pressure, surface tension and viscosity. So with this we can conclude this topic of this liquid state, and by which so far we have completed gaseous state, liquid state, the two physical states of matter, and then we left with the third one, that is solid state. So in the next lecture we discuss about the solid state.